What most people don't know is that those two edges that you're skating on are within 1/1000th of an inch of one another when that skate is properly sharpened. When those edges go out of level, one direction will feel sharper than another. That can result in someone turning left and feeling like there's a lot of grip, and then they turn right and they just fall. When you're playing at the highest levels, like the NHL, those skaters can absolutely feel even a couple thousandths of an inch difference between those edge heights. We came into the market to create a product that would allow anyone to have pro-level accuracy to sharpen a skate at home. And if we were going to disrupt this market, we had to solve some really key problems, some of which were incredible accuracy and incredible safety. We knew this product right out of the gate had to be perfect. If there was any flaws, we would go nowhere.
At the same time, the technical challenges were pretty big because everything in skate sharpening and grinding, a grinding operation is about precision. We measure the relative edge height of the skate in thousandths of an inch or fractions of a thousandth of an inch.
We use simulation quite a bit here because there are many really deep technical problems associated with structural integrity, heat transfer, kinematics, making sure motor arms and normal forces are all maintained through the sharpening process.
I used different 3D tools before that, and they weren't parametric based, and so that was a real struggle. And so with Solidworks, it just makes it possible. The iteration component of that is just so much faster and more powerful.
We just got to keep engineering this. It's got to be accurate. We need super great bearings. We need super straight shafts. We need everything about that product from day one eventually was the DNA that passed that NHL test later on. So there's a lot of the simulation side of Solidworks as well, helping us be smarter about our design, do less iterations empirically, you want to build less prototypes.
When we're clamping the skate, we are looking at the deflection of that main structural component. How thick should the wall thicknesses be? So it's really an optimization element in the design.
We showed this product, and that equipment manager ran a pair of skates and then held it up into the light and looked at the edges and looked at the levelness, and they turned around to all their friends in the audience and they were like, not bad. And then it just, from there, it took off. It felt great because it was validation that I wasn't crazy in the beginning. The last time somebody innovated in skate sharpening was 100 years ago. So with CAD tools, 3D printing, RFID and Wi-Fi and everything that was available to put into a product, this was just an absolute blue ocean of opportunity to go into skate sharpening.
We'll continue to evolve the sharpener. We'll make it faster, we'll make it lighter, we'll make it less expensive. And I think we'll continue to innovate that way. We'll find things that really fit with our customer base and with hockey.
Where your skates are touching the ice, it is the foundation of everything in hockey. If your skates are sharpened as they should be, you're able to perform at your very best, and now you can achieve everything you want to as an athlete, and your skates aren't going to hold you back.